Every second of every day, something invisible keeps modern life alive. Lights turn on, factories run, data moves, and if it stops, everything stops. In China, that invisible system is larger than anywhere else on Earth. A power grid so massive, so complex, and so expensive that once it was built, it could no longer stop. China's rise did not begin with skyscrapers. It began with electricity. Without power, there is no industry, no growth, no control. And as China's population exploded, its hunger for energy grew even faster. By the early 2000s, China faced a crisis. Demand was outpacing supply. Blackouts spread across cities. Factories shut down without warning. The economy was growing, but the grid could not keep up. Something had to change. China made a decision few countries would dare. Instead of patching the system, it would rebuild it entirely, not region by region, nationwide. The goal was simple to say, but almost impossible to execute. Create a single unified power grid, capable of moving electricity across thousands of kilometers, from remote hydro dams in the west to megacities on the eastern coast, from deserts to coastlines, from nowhere to everywhere. This required a new kind of technology, ultra-high voltage transmission, lines carrying power at levels never used before, stronger, faster, more efficient, and extremely dangerous. One mistake could be fatal. China invested more than $200 billion. Power lines taller than skyscrapers, cut across mountains, rivers, and cities. Substations the size of airports were built to control the flow. From the air, the grid looks like veins. From the ground, it feels unstoppable. But building the grid was only part of the challenge. Controlling it was something else entirely. A system this large cannot be managed by humans alone. So China turned to automation. Algorithms decide where power flows. AI predicts demand spikes. Systems rewrote electricity in milliseconds. Efficiency replaced flexibility, and flexibility was sacrificed. The grid became one machine. And machines do not like interruption. Entire regions now depend on centralized control. A failure in one area can ripple across provinces. Blackouts no longer stay local. They cascade. Still, the grid delivered what it promised. Factories ran nonstop. Cities expanded. China became the world's manufacturing center. The grid powered economic dominance. And that made it untouchable. Because once an entire nation depends on one system, shutting it down is no longer an option. But behind the success, new risks were quietly growing. Risks that could not be solved with more money, risks built into the system itself. And the more the grid expanded, the harder it became to control. A system designed to never fail. On paper, China's power grid is a triumph. Electricity flows across thousands of kilometers. With minimal loss, power from western hydro dams lights up eastern megacities. From deserts to coastlines, the system works, most of the time. But systems built for efficiency often trade resilience for control. China's grid is no exception. Its greatest strength is also its greatest weakness. In traditional power networks, failures are isolated. A transformer goes down. A neighborhood goes dark. In China's ultra-connected grid, failures travel. A disruption in one region can trigger chain reactions elsewhere. The grid does not break in pieces, and it breaks in waves. This became clear during extreme weather events. Heat waves pushed demand beyond predicted limits. Floods damaged substations. Ice storms snapped transmission lines. Each time, operators fought to stabilize the system. Each time, success depended on speed. Milliseconds mattered. Behind the scenes, algorithms made the decisions. Where to divert power, which regions to prioritize, which areas would go dark temporarily. These choices were not moral, they were mathematical. Efficiency, not fairness, ruled the grid. Entire cities experienced sudden blackouts. Factories shut down mid-production. Transportation systems froze. Data centers switched to emergency power. Life paused and then resumed. But the warning was clear. The more centralized the grid became, the less forgiving it was. Human oversight struggled to keep up. Engineers monitored screens filled with data streams. moving faster than reaction time. Automation was no longer a support system, it was the system. Cybersecurity emerged as a new battlefield. A grid this advanced attracts attention. State actors, hackers, sabotage. Officials insist the grid is secure, but no system is invulnerable. And testing those limits could have nationwide consequences. The grid also became a geopolitical tool. Control of electricity means control of industry. Regions dependent on centralized power lost autonomy. Energy decisions became political decisions, and energy security became national security. If this story made you stop and think, take a moment to support the video. Like it, share your thoughts in the comments, and subscribe to Megaphiles TV for more deep dives into the projects shaping our world behind the scenes. Your support helps these documentaries exist. As renewable energy expanded, the grid grew even more complex. Solar and wind are unpredictable. Power spikes and drops had to be balanced instantly. The system became tighter, less margin for error, more pressure on automation. Meanwhile, consumption continued to rise. Electric vehicles, data centers, high-speed rail, every innovation added load. The grid expanded again. More lines, more substations, more dependencies. The result was a paradox. The grid became stronger and more fragile. Maintenance became constant. Entire sections of the grid were never allowed to shut down. Upgrades happened live. Mistakes carried national consequences. Inside China, questioning the grid was not common. The system symbolized progress. Admitting vulnerability meant admitting limits. So risks were managed quietly, out of sight. The world watched closely, because China's grid is not just China's problem. Global supply chains depend on it. If the grid falters, factories stop. If factories stop, the world feels it. The grid had crossed a critical point. It no longer existed to serve the country. The country existed to support the grid. And that is when stopping becomes impossible. Because systems this large do not fail gracefully, they collapse. But collapse is not inevitable. Yet, the question is not whether the grid has risks. It is whether humanity can manage what it has built. A system that can't sleep. Power grids were never meant to think. They were meant to deliver. But China's grid doesn't just deliver electricity anymore. It predicts, it decides, it reacts every second. At this scale, there is no off switch. Shutting the system down would be more dangerous than keeping it running. Hospitals depend on it. Transportation depends on it. Communication depends on it. Entire cities breathe through the grid. Engineers call this continuous operation. In reality, it's permanent tension. A system stretched across a nation must work perfectly every moment, because one failure does not stay local. Simulations have shown the risk. A cascading blackout could spread faster than human response. Substations overload. Lines trip automatically. Power reroutes until there is nowhere left to go. The grid begins to eat itself. China has built safeguards, redundancies, firewalls, emergency protocols. But no safeguard removes complexity. It only adds more layers, more code, more automation, more things that must work together flawlessly. The future only increases the pressure. Artificial intelligence will optimize load balancing. Smart cities will demand real-time energy. Millions of electric vehicles will plug in simultaneously. The grid will grow again and again. At some point, growth becomes dependency. Stopping expansion would destabilize the system. So expansion continues, not because it's optional, because it's necessary. This is the hidden cost of mega infrastructure. Once built, it defines the future. Decisions made decades ago lock generations into a single path. China's grid is a masterpiece of engineering. It powers progress, it fuels innovation, it keeps 1 billion lives moving. But it also demands obedience to the system, to the schedule, to the algorithm. Around the world, other nations are watching, learning, copying, scaling, because the same logic applies everywhere. The bigger the system, the harder it is to change. This is not a story about failure. It's a story about momentum. about how humanity builds systems that move faster than its ability to control them. And once they reach a certain size, that they no longer ask permission. They simply continue. If you want more documentaries that go beyond headlines and reveal the hidden cost of the world's biggest projects, like, comment, and subscribe to the channel. These stories don't end when construction does. They're only just beginning.